Hello student, this video on Motion and Time Part 2 is brought to you by Gyanoda High School. Please stay at home and save your life.
Our next topic is slow and fast motion. So student, you suppose that you are sitting near a window of a moving bus and looking outside. The trees outside will appear to be moving backward. But to a person standing on the road, the trees will be appear stationary. For us, we are sitting inside the bus, so we will moving bus, so we will feel that this all the trees are moving backwards. But those is standing outside the road, for him the plants are appear stationary. Similarly, the person sitting next to you will appear at the rest to you, while both of you will appear to be in motion to the person standing on the road. So those people is sitting in near to you, that appear to it is rest position. But when any person look from outside, standing outside, so he will see bus is moving means we are also moving. So like that, in order the words, motion is a relative term. Everything in the universe is in motion. Objects move in different ways. Their movement requires energy, which can be internal or provided externally. Also, the motion of the objects may be slow or fast. You must have noticed that some vehicles move faster than the others. For example, two persons start their journey for the same destination, from the same place and at the same time. One is on the motorbike and the other is on a bicycle. Who will reach the destination first? Obviously, the person on the motorbike. A vehicle may have slow and fast motions at the different time. For example, a car moves slowly on the curved road, but it's moves fast on a clear road. So through these two different examples, we understand that what the two things are very necessary for the motion, or any object will be fast or slow motion. So we can decide it anything will be move fast or slow. We need to measure. Number one, the distance traveled by the objects. And number two, time taken to cover the distance. So we have to understand what is the object is, whether it is a bicycle or motorcycle. And next thing is we have to see the time taken by an object. It is slow or fast. Means in on the curved road or in the hilly road, the object will be moved slowly. And if it is clear road, so definitely object will be moved faster. So like that, we have to notice the distance traveled by the objects, and second thing, the time taken to cover this distance. So like that we can understand this is the slow motion or fast motion. Another example, if two car is moving from the same place and they have to go in the same destination, which one is take less time to cover the destination or distance is said to be faster as compared to others. Therefore, we can say slow and fast are relative terms.
Our next topic is speed. All of you must be familiar with the term of speed. We say that vehicle moving faster has higher speed and vehicle moving slower has lower speed. A higher speed indicates that a given distance has been covered in shorter time, or a longer distance is covered in a given time. So like that we can define the speed. Speed equal to total distance covered by an object d divided by total time taken by the object t. So the formula of speed is s equal to small d by t. The speed calculated in this manner is the average speed. Our next topic is uniform motion and non-uniform motion. In our daily life, very few objects move with a constant speed for long distance or for a longer time. And the second thing, if the speed of an object move along a straight line keeps changing, if it is changing daily, its motion is said to be non-uniform motion. For example, a car moving on the plain road, so it will be cover same distance in the same interval of time. Like a car moving from the Raipur to Jagdalpur, the distance will be 300 km, and it reach Jagdalpur the same time daily. If it starts at the night 10 p.m. from the Raipur, it reaching morning 6 o'clock daily. So like that we seen that the car is coming this same time, they cover the same distance. So this type of motion is said uniform motion. Another example, a car is coming the same road but time is the different. One day is reaching in 6 o'clock, second day it is coming to the 7 o'clock, third day it is coming 8 o'clock, next day it is coming 5 o'clock, next day it is coming 4 o'clock. So like that we see the different car are coming in the different time. Distance is same but time taken by the second car is different. So we said this is non-uniform motion, means it will not move same distance in same time. Like that we can clear that non-uniform and uniform motion. One car coming the same time and cover the same distance daily, it is said to be uniform motion. And second number not cover the same distance in the same time daily, it's come in different time, it is called non-uniform motion. The next topic is unit of speed. The SI unit of distance or length is meter and that the time is second. So the unit of speed is meter per second. But if the distance covered and time taken are very large, like in case of the aeroplane, so we generally use kilometer per hour. Our next topic is measurement of time. In ancient time, people took help of the natural event to measure the time, since they occur at the regular interval. For example, the time interval between one sunrises and the next is called one day. The time period of one sunset to sunrise is called night. Similarly, time interval between one new moon to the next moon is called 1 month. So like that our ancient people are using these natural events to understand the day, night, month, as well as the time taken by earth is complete one revolution of the sun is measured as a 1 year. So like this, through the natural events they understand the time period. After a long time, different people had invented the different devices to measure the time. They as follow. Number 1 is sundial. This device was used long ago to measure the time of a day. It works on the principle that as the position of the sun in the sky is changed, so did the position, and they see the length of the shadow and they understand the time. Second device is sand clock. This device was used by the Romans. It worked on the principle that all the sands from the upper chamber falls into the lower chamber in a fixed amount of time. This fixed amount of time was unit of the measurement of time, commonly called an hour. The sand clock is also known as a hourglass. Next is simple pendulum. Famous scientist and astronomer Galileo Galilei discovered that the swinging pendulum takes a fixed time to complete one to and fro motion. Therefore, it said oscillation. Clocks and watches that measure time accurately were made after the discovery of simple pendulum by Galileo. If we will observe the pendulum, a simple pendulum consists of a weight called bob tied to a string. The other end of the string is tied to a rigid sub for support. When the pendulum is at rest, it is called its main position A. When the bob is displaced slightly and released, it begins to move to and fro motion about its main position. The time taken for one true and fro movement from the A to B, B to A, and A to C, again C to A. It's always is the same as long as the length of the string is not changed. And also there is no resistance of the air around. One complete to and fro motion or movement is called one oscillation. The time taken by pendulum to complete one oscillation is called its time period. This principle of the simple pendulum is used to make the pendulum clock. The pendulum or in a pendulum clock swing continuously. This action will be spring and control the action of its hand. Nowadays, most clock and watches have the electric circuits. With one or more cells, these watches have quartz crystal which can vibrate very fast and at a very precise rate. These watches measure time much more accurately than the pendulum clock. Next thing is stop clocks or stopwatches are used in the laboratories and sports to measure short interval of time. 1 by 10th of the second accurately. They can be started and stopped anytime at we want. So like this we had seen the different people use different devices to measure time. Previously the people used the natural things, then after they start the shadow of the sun, then after they use sand clock, then after they start using pendulums, and slowly they start the electric circuit and quartz crystals. Nowadays, several digital watches are available in the market. These watches display time in the digits and can be used stopwatches as well. So like that, we see that different people use the different devices to measure the time. Our next subtopic is unit of time. The SI unit of time is second. It's shown by the small s. Different units of time are used depending upon the requirement. For example, age of a person expressed in the year. The time taken to reach our school or market is expressed in hour or minute. So like that we can say that 1 hour equal to 60 and 1 minute equal to 60 second. The smallest time interval that can be measured by the commonly available watches in 1 seconds. However, nowadays special clocks are available which can be measured time interval in the small as 1 millions means microseconds or the nanoseconds of a second clock. So we will see the calculation of speed. So now you know that how to measure the distance and the time. So you can calculate the speed of the moving object. Example, a car takes 30 minutes to cover a distance of 36 km. Calculate its speed in kilometer hours or meter per second. Solution: distance covered D is given in 36 km and the time is taken to cover this distance T equal to 30 minutes. So for here we have to convert minute into hours first. So here we know that 1 hour equal to 60 minutes. So like that 1 minute equal to 1 by 60 hours. So same here 30 minute equal to 30 by 60 hours. So when we will be divided it, we will get 1 by 2 hours, means half an hour. Now we have the distance in kilometer and time in hour. Now we have to take the speed distance by t equal to 36 by half. It means speed equal to 36 into 2 equal to 72 km per hour. Now we have to express the speed in meter per second. Distance had already given in the kilometer, so we have to convert here first the kilometer into meter. So we know that 1 kilometer equal to 1000 meter. Like so 36 kilometer equal to 36 into 1000 meter. So distance come 36,000 meter. Time had given in minute, that we have to convert into second. So for that 1 minute equal to 60 second, 30 minute equal to 30 into 60 seconds is equal to 1800 second. So here we got distance in meter and time in second. So we can take out easily the speed meter per second. So speed equal to d by t, d equal to 36,000 and time equal to 1800. So when we will divide it, we will get the answer 20 meter per second. Means that cars move 20 meter per second. In 1 second it moves 20 meter. Like that we can get the speed of an vehicle. Next example, an express train takes 6 hours to travel from Delhi to Gagal or Himachal Pradesh at a speed of 80 km per hour. Find the distance between the New Delhi and Gagal. So solution, in this question speed had given and time also had given. Time is given 6 hours and speed had given 80 km per hour. So like that we can take out the distance from here. The formula is speed equal to d by t, or we can write d equal to s into t. So speed had given 80 km per hour and time is given 6 hours. So answer will come is 480 km. So distance between the Delhi and Gagal is 480 km. Next example is distance between two cities is 522 km. How much time will a train take to cover this distance? At the average speed is the 87 km per hour. Solution, here given distance d equal to 522 km, speed 87 km per hour, time equal to, we have to take out. We know that s equal to d by t. So like that we can take out the time equal to d by s. Put the number in formula, d equal to 522 km and s equal to 87 km per hour. Here kilometer will be cut and h will be transferred in the upside. And after divided by the 8752 come the 6. So the train will take 6 hours to cover the distance of 522 km at the speed of 87 km per hour.